Hello everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we'll be solving minimum window substring. This is one of the most important sliding window problems asked in interviews. It looks simple, but many people get wrong answers even after writing what looks like a correct code. In this video, I'll explain the brute force approach, why it fails, and then I'll walk you through the optimized sliding window solution with complete working code. So the problem states that we are given two strings S and T of lengths M and N respectively. We need to return the minimum window substring of S such that all characters of T, including the duplicates, are present. If no such substring exists, we need to return an empty string. So in brute force approach, we will generate all the possible substrings of S, and for each substring, we check if all the characters of T are present. If yes, we will compare the length and store the minimum one. So the code for this goes like this. Um, so we need a minimum length initialized with the maximum value, and we need an answer to track the minimum answer, and we would iterate all over the array. I less than es dot length and j would start from I till the length of the array, length of the given string, yes. And now first we will find out the substring present between these two iterations. Let's say it sub, and we will get the substring of I till j. So we need j plus 1. Now if it contains all the characters of substring in T, then let's implement this contains all later. First we will update the minimum length. If substring's length is less than minimum length, then minimum length would be equals to substring length, and answer will be the substring, and at the end we would return the answer. Now we also need to implement the contains all method. The return type is boolean, and we are passing two strings. So let's say it yes and T. We need a frequency array to track the frequency of all the characters. Let's say its size is of 128, and for each character C in yes dot to char array, we would update the frequency array. Now for each character in T, we would check if it is present or not. So we would check if the frequency of the C, we'll decrement it later, if this is less than or equals to 0, then we would return false. That means it is not present. Otherwise we would return true at the end. Why this? Okay, let's run the code. Okay. Okay, it is working. So the time complexity would be O of n cube because we use two for loops here, and inside contains all we have other for loops, and the space complexity would be linear because though we used a frequency array, the size of it is 128, which is constant. That's why the space complexity is linear. Now we need to think of an optimized approach. So instead of checking all the substrings, we will use a sliding window and we would expand until all the required characters are included. Then we will shrink to find the minimum window. So this avoids repeated work. For this, let's comment the brute force approach. And now for this, the base condition would be if s length is less than t's, then we would straight away return empty. Now we need a frequency array of size 128 like we used in brute force approach, and we would update this frequency array with all the characters of t. For each character c in t dot to char array, we would update the frequency. Now we need few variables here. We need left starting at 0, we need right starting at 0, and we need a counter of size t length, and we need minimum length like we used in brute force, initialized to the maximum value. And I think we also need a start to track the start of the answer. Now while this right is less than s dot length, okay, let's get the character first. Character c is equals to s dot caret right. Now the c has the right character. Let's check if it is present in the frequency array. If frequency of c is greater than 0, which means that is present, then we would decrement the counter, and then we would decrement the frequency array, and we would increment right. Now let's shrink the window. While count is 0, if we need to update the minimum length, if right minus left is less than minimum length, then this would be the minimum length, and the start would be at left. And then now we need to check the left character. Left character would be the s dot caret left. We would increment the frequency of left char, and we would check if it is greater than 0. If frequency of left char is greater than 0, then we would increment the count. Then we would increment left, and that is it. At the end, we would check if minimum length is same as the value initialized. If yes, it is not found, then we would return empty. Otherwise, we would return the substring from the start till the minimum length. Okay, let's run the code. It is working. Let's submit it. Okay, it is accepted. So the time complexity would be O of n because we are doing it in a single while loop. This is just for the shrinking the window. And the space complexity would be O of 1 because we are only using an extra array, but that is also constant of size 128. So the space complexity is linear. So the quick edge cases are if the t length is greater, if the length of t is greater than s, then we would straight away return empty, and the repeated characters in t will match the frequency, and multiple valid windows. If we have multiple valid windows, then we will return the smallest of them by updating the minimum length. So this problem clearly shows why the brute force is easy but it is slow, and how the sliding window optimizes the repeated work, and why this solution is commonly asked. So that is it for today's problem. I'll see you in the next video with another sliding window pattern. You can dry run this code. Thank you for watching.